Hello everyone, I am Bradley Sward, and in this video we're going to cover the Advent of Code 2023 Day 3 solution. The problem is gear ratios. I'm solving the problem in the Python programming language, and a tiny little thing held me up for quite a while. So let's talk about it. Let's take a look at it. And so for the problem here, at least for part one of the problem, you have a grid of data, you have numbers in here, you have periods, which are basically just empty spaces, and you have these parts that are anything that is not a number and is not a period or a dot. And these are called their schematic parts or something, yeah, engine schematics or whatever. And so basically you are asked for each schematic part, or at least for each number, is a number touching diagonally, horizontally, or vertically a schematic part? And if the answer is yes, you sum up all the pieces together and you get, in this case, you get the answer 4,361. The only two numbers that don't get added in is the 114 in this case, because you can see that there's dots surrounding it, and same with the 58. There are dots surrounding the 58, but everything else has a schematic part touching it. And so and you can see here, I'm going to get an answer of 525,181 in a second. But let me show you the code that I used to get there. So here it is. Yep, here it is. So in my case, what I did, my data structure was to go through the file character for character and basically figure out where are the numbers and where are the symbols in the grids and keep track of the row and column numbers for each of them. And so the symbols was pretty easy because the symbol is only one symbol. So the symbol can just be basically just the row number, column number of where it was found inside of the data structure. And then just to debug the thing, I kept track of what the actual symbol was. You don't actually need that to solve the problem. But basically for every time I encountered a number, I took basically, the number that I had previously, I multiplied it by 10 and added the number just so I could continue the number along. And basically also I added the column number to a list. So I have a row, which is just a single number because the values for the numbers themselves are always horizontal. And so I don't have to worry about having more than one row number, but I do have to worry about having more than one column number for any of the individual digits of the number. So in that case, I'm keeping columns as a list, or I could keep it as a tuple. That would be easy just as well if I was using a set or something like that. So anyway, so that's how it goes. If I encounter a number, keep the number going. But if I encounter any other character, then I have to do other stuff. So if it's a non-period character, I add it into the symbols list. And basically, if I hit any character that is either a period or a special character, as long as the number is greater than 0, I put that into the numbers list. So this code will get you there, and you can kind of half see it. So here we go. I can kind of half see it here. You can see that the number list here has, if you check it against my data here, oops, you can see that for number 733, from row 0, columns 3, 4, and 5 hold the number. And for row 0, columns 13, 14, and 15 hold this number, and so forth and so on. And so that's for the numbers themselves, and then the symbols you can see here at, I guess this first row doesn't have anything, so at row 1 column 4, that's where I have the asterisk, and then you can kind of see how this goes. So the first part of this is just to develop that data structure. So now I can do the second part, and I can say for every number, is that number touching a symbol? And you can see that code down below. And so I could get rid of this part here with the 0, 0. I just thought maybe there was a bug in it or something like that. But basically you take, for every number, you test it against every symbol, and if any symbol, basically horizontally, vertically, or diagonally touches that thing, this is what this is doing, saying offset, just, try to move in one of the 8 directions. And if you find that the values are equal, the row numbers have to be identical, but then from the location for the column numbers, the column number just has to be in the data structure itself, as opposed to because it could be 1, 2, or 3 values inside of that list. So if that is the case, then I know that the number is found, and then I can add the number in, and I can break out, and I can continue forward. So for every number, try to test every symbol and see if I move the symbol around in all of the 8 directions, does the symbol touch the number? And if that's the case, add it all together, and then, just by saying if I run this, it takes a little bit longer because this could be more efficient, no doubt. But you can see here that you will get the 525,181 number that we were talking about. Come on, there it is. Okay. So then now coming back here, thinking about this a second time for part two, and now instead of thinking it from a number by number basis, they want us to think about it from a asterisk to asterisk basis. So they were saying like now for part two, find all the asterisks and find all the asterisks that are attached to and touching exactly two numbers. And when that happens, multiply those two numbers together and sum up all the multiplications, and you'll get the answer that they're looking for. So in this case, 467 times 35 is the first part. And then the second part here, it's 755 times 598 to get the second part. You add all of that together and you get whatever you get there, 468,000. So you see here, I'm going to get this large number here in a minute. And let me just show you that here for part two. So the first part of this is exactly the same. I didn't modify any of this, or maybe I made this a tuple because I did use a set down here and I don't know if I had to or not, but I did it just to make sure that as I was going through symbol for symbol, that I'm not using the same number more than one time. My hypothesis is that the set is necessary, but I'm too tired and it's 1:30 in the morning and I want to go to bed. And so I don't necessarily care enough to look into this any more than I have to get that job done. So first part here is the same as part one, but now I'm doing this on a symbol by symbol basis, and I'm checking every number against it, and I'm basically saying with the same amount of code here, I go, well, if I found it, if I found a value here, oh, interesting enough, I did not put an asterisk into, or did I do that somewhere? No, I did not. That's interesting to me that to get the correct answer, I did not put an asterisk anywhere. So according to the data itself, the only asterisks are attached to two parts. That's interesting. Yeah, whatever. That's just happened to be how it happened to be. And so, for other data sets, maybe this will work, but this will work, and maybe this won't. But anyway, that's just an interesting thought as I'm going through this. But just to say here, for every symbol, let's test every number and every offset. And again, now, if you find that they're touching, we're going to add it to the list or add it to the set. And then break out as, just like we've done before. And basically now when we break out, instead of everything we did in part one, now we'll just say, okay, if the found list only has two values in it, then I will multiply all the values together and add that to the total. And just go through things one by one by one by one by one. And when I get that, I will run this guy. And I don't know how long this one takes, but this starts with the 8, and this is that huge number that we were talking about that matches up with everything we see in the solution and on the website there. There is my answer, 848 and 2 and so forth and so on, which matches up here, 848 to whatever. You get the answer there. So again, I'm not 100% certain that my code will work, and a couple of you, if you watch this, maybe will ding me for that. But I only have two data sets. I only have this data set, and I have the data set for that I was given. So I really don't know if everything works. I would need more data in order to account for this. Oh, and one thing the reason why everything took me forever to do this time around was that let me pull up the data here for this. And the data set itself, that the example data set did not match up with a problem that I encountered here. And it's down a little bit. This 562, at least in my case, when the number ends a line, it was not, my code could not handle that because it wasn't looking for the end of the line character, and it just didn't know to add this number to the list if it was attached to a schematic part. So all I had to do here to make this thing actually work, and this one little tiny thing probably cost me half an hour, 45 minutes while I was doing other things, thinking or whatever. But basically, by adding a period to the end of everything, I don't have to worry about that anymore. So for part one and for part two, you see that basically by adding a period to the end of that line, and I did that for both parts because they're both the same here to do this, that accounted for everything. But the example data set didn't have that, and that's where my problem was. You can see that there were that like in this case there were no numbers that were on the final column of the row. And if that was the case, I probably would have found this a lot simpler and a lot simpler. Well, anyway, so please comment if you care. I appreciate you guys watching this as always. This is always a fun week or two for me until the finals week and everything gets going here, and I have to put on my grading hat and complete the term. But please let me know if you know any way better, because this is just kind of hacky. I got a solution, not proud of it, but it works. And now I can go to bed. So I hope to see you guys in future videos. Thanks for watching. Have a great day, everybody. Take care, and we'll see you next time.